Our next speaker, who I don't see showing up as a panelist yet, please join. Vincent Sarago will be joining us. Vincent is from Development Seed. He's going to be talking to us about simple and fast OGC servers for PostGIS with TiFeatures and TiMVT. I see Vincent's little icon showing up. That's good news. Hello, good to see you. I'm going to turn on your audio. Can't hear you though.
Is it working now?
It is.
Okay, cool. Sorry about that.
No problem. So you've been a busy person. You've built some fancy software. You want to tell us about that?
Sure. Yeah, let's get going. Okay, I'm going to share my screen.
Okay.
Right. Hope it's going to work fine. Okay.
It works fine.
You should be able. Excellent. Yeah. So yeah, thanks, Paul. So first, I'm really glad to be here today. I feel like kind of an imposter because I'm not a PostGIS or database person. I'm more a raster person, but yeah, I'm going to talk about two projects that we have been working on. So yeah, my name is Vincent Sarago. I'm a software engineer at Development Seed. Yeah, again, I'm a raster person. Some people know me because I've worked on a project called TiFeatures, and which is a dynamic raster tiler. So it's a Python project we built at DevSeed, which helps you create like map tiles from raster dynamically. So you have a data source, which is a raster data set. You put TiFeatures in middle, in between the data set and the client, and ask TiFeatures to read the raster, and it will return a tile for your map client to load it. So that's why we started to work on the TMVT project and TiFeatures project. So yeah, we had TiFeatures, which create raster tiles, and we say, hey, would it be cool to also have this kind of project that create like map tiles dynamically, but for vectors? And then use PostGIS as a data store instead of using raster. And so that's how we started TMVT. So again, I'm not the only one working on that. I've worked a lot with David Bittner, who is going to talk later today. But this is like a real teamwork on those two projects we've been working on. So yeah, let's start with TMVT then. So TMVT, again, it's a Python project. It's a Python module built on top of FastAPI. So FastAPI is a great framework that lets you create like a web API with Python really easily. It comes with a lot of features and it's pretty fast. So yeah, the goal of TMVT is to create map tiles that you can display on the client. And usually the map tiles that you load on the clients, either you go on a Google Maps or whatever map application, usually the vectors are like pre-generated. So the map tiles are pre-generated, they are stored in the cloud storage. And then there is either a server or a CDN on top of those that the client will use to get the tile from. So it involves a lot of like processing to cut the tiles and to pre-generate the vector tiles and then store the vector tiles in the cloud storage. And so there are a lot of costs. It's pretty fast than when all the tiles are created, but once you need to update the tiles, you have to redo everything again. So this is like the classic way of having tiles that are statics. And so with TMVT, we want to have everything dynamic. So you have a web client that will call TMVT, and TMVT will read the database for the data source and to get the geometries from the database and create the vector tile dynamically. So you only have the data store, which is the database, and then the server. So you remove like every pre-processing steps. You can change the tiles that you want to create dynamically. And so you can adjust the properties dynamically. You can like adjust the projection of your tile dynamically. So you don't have to pre-generate all the tiles in all the projection that you want to support, for example. So which is what the goal of TMVT is, like to plug it to the data store. So which is like can have tables, view, and also custom functions to create like tiles. And so simple most of features of TMVT. So again, built with Fast API, so it's fast and it's pretty simple. We try to ease the integration to other applications. So you can have the TMVT endpoints plugged into your own Fast API application if you have a Fast API application in place. It's fully asynchronous, so it tends to be fast. We support table and functions. We support multiple tile matrix sets, so multiple projections. So you can create tiles in Web Mercator, but also in WGS 84 and other projections, and you can add your own projection or tile matrix sets if you want. We shipped TMVT with Web Viewer, and something that was important to us was for TMVT to work with your database, you only need select privilege. You don't need write privilege to the database. We don't want to write to your database. We just want to read the dataset from the database. So this is true for tables, but also for functions layers. So the functions are not right. The custom function that you want to create tile with are not written to the database, but like they are executed on the fly. And then I will show you later some example. And so the function can be like version control, and you don't write to the database, so you don't change the database. It's like really a service that you plug to your database. So one important thing about TMVT, you don't have to fork it. You import it. You install TMVT. It's a proper Python module. You just do pip install. If you know Python, you do pip install TMVT, and then use ASGI service to like deploy your application. So you do uvcon, TMVT, main app, and then you have your TMVT application launched. And so it's pretty simple, like 2 command lines, and you can plug TMVT and have an application, demo application launched, plugged to your database. So Fast API, I say TMVT is built on top of Fast API. It's create like really simple, really nice APIs. It comes with automatic documentation. So this is the Open API documentation that is pre-generated from Fast API. So you can see what endpoints do you have, what endpoints parameters needs, and what are the outputs models for each specific endpoint. And so TMVT comes with a viewer, like a web map viewer that you can see the different tables that you have in your database. And as we support custom functions. So the hexagons we are seeing on this page are not like a table, it's a function. Every time we call for a tile to be loaded on the map, TMVT is going to create the hexagons, and you can also interact with query parameters to change the size of the hexagons. And this example is taken from Paul's Crunchy Data project, PGTileServe, which is like exactly, we get the inspiration from PGTileServe and Martin are 2 great projects that does almost the same, creating vector tiles from PostGIS. And so yeah, so I think I have time for a quick demo. So I'm going to stop sharing this screen and go to desktop. Okay, right. And so again, so I'm going to, so it's really small, but don't worry. I'm going to launch my database and then launch my TMVT project. So this is the tables that I have in my project. So, and we can see the tiles for each table. So this is, so the tiles again are created dynamically. So, and you can access, like, because it's vector tile, you can access the properties for each geometries. another project, another table. Maybe I can make it bigger. So this is, again, we store the Landsat grid in PostGIS, and we can create a vector tile from it, interact with each features. And yeah, so let's see the, yeah, I've got functions in the TMVT project I can use. Yeah, I was talking about the hexagons. So let's see the hexagons. So viewer. So again, we can see that the tiles get created on the fly. It's really fast. But like if I change the size of the polygons of the hexagons, sorry, and make it like maybe so big polygon, big hexagons, so you can see that the tiles get created on the fly. And so if we can get crazy and like create like a lot of hexagons. But yeah, so this is like a function, a layer function. And so yeah, so let's go back to the presentation. Sorry about that. Okay, should be back on the presentation. So yeah, it was pretty fast, but don't worry, everything is explained on the project documentation, and I'll be also happy to answer questions at the end. In terms of performance, we found that TiFeatures, TMVT perform as well as two great projects like PGTileServe and Martin. Sometimes they're faster, sometimes they're slower. But yeah, the goal was like to make something which was fast, but also that which was written in Python, so we could integrate with other applications. And so yeah, we are still working on TMVT, but right now we are really happy with the performance that we have. All right. Yeah, 15 minutes, great. I can, yeah.
Boom, 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 boom. Just like
yeah,
that.
I'm sorry.
Can't keep
You have a
looking
question?
down.
Oh.
I do have questions, yeah. Well, I gotta start with the big one right off the bat. So like, why another tile server, man?
Yeah, I know. So basically we wanted something written in Python that we could integrate with other applications. So for us, having to only learn and understand one language for some project was important. And I'll show at the end of this at the end of the presentation, like how you can easily integrate like your FastAPI application to other FastAPI application. So you can extend, really easily customize. And so that was the goal, like having, like, because I don't want to learn Go. I mean, I know it's a great language, but like, I didn't want to learn Go to really understand how the project was working. Yeah. And so, but yeah, that was the main goal, like having like a project written in Python in FastAPI, using FastAPI that we can use to expand and customize easily.
Cool. Yeah, I'm jealous of your open API. That's very nice. I want to have that. I got a question from Scott Parks. Scalability. How does this perform under high demand?
Well, it depends on the infrastructure that you are using. We have TMVT deployed on the Kubernetes cluster for one project, and it seems to work well. Like I guess it works as well as the other project like PGTileServe and Martin. I would be more than happy to have more tests and to have more people trying that for me. But yeah, I know that it's working well for our use case and for the project that we are working on right now. But yeah, I can't tell. I don't have specific numbers.
It's hard to have any specific number for this. My own rule of thumb is that it's going to bottleneck on the database first. And then if you're really worried about scalability, you should build in some caching layer of some sort, even if it's a very narrow, like 1 minute, 5 minute caching layer.
Yeah.
Question from Daryl Vandervert. I'm using TiMVT and I love that it's written in Python. So there you go. I run it in a serverless Lambda setup, which gets to my other question, which I wanted to ask. What is the best way to manage database connections? I'm now experimenting with RDS proxy. Any suggestions?
Yeah, so for example, using Lambda, it's pretty dangerous because there is not a bug, it's something kind of feature using Lambda that's the life. So if you use TMVT right now in Lambda, the poles the connection poles are going to get created and closed every time you make a request. So it's not cached. So you are like, so there is way to avoid that, but it's not ideal. So yeah, so there is a small bug that we like someone has to fix or whatever. And so, but yeah, using Lambda is great because you can scale really fast, and you just have to make sure that you don't create like too much connections. Also make sure that you only get one connection per pool for Lambda, because you cannot reuse the same connection. So yeah, yeah, usually we use Kubernetes right now. But yeah, you can. I've got an example using AWS Lambda for that. But yeah.
Question from Paul: what styling methods are available? SLD icons, colors. So this is
none.
Exactly.
None. It's pretty basic. Like it just serves like it serves you like the vector tiles without any style. Yeah, I think the Martin project is doing that. I'm not sure if PG tiles does that. But yeah.
Not yet. It's like, so the styling, because these are vector tiles, the styling is applied at the client side by the browser. So the servers would only do styling insofar as they might store some styles on the server that the client can then reach back and apply.
Yeah. Right.
Can
we go to TiFeatures, or I won't have time?
Oh my God, I forgot you had 2 talks. Sorry.
Yeah.
That's why you were so quick.
Sorry.
Yeah. Move on.
Sorry. Okay. So yeah, TiFeatures. I'll try to be quick then. TiFeatures. So TMVT create vector tiles, and TiFeatures return features. So we built TiFeatures to follow the OGC feature API, which is a OGC specification. And we try to follow as much the core spec and filtering as much as specification they made. So right now in the OGC feature API, there are 3 parts. Part 1, the core part is like listing the collection you have in your database, filtering by geometries and by time. And that's pretty much it. It's pretty simple, like way to interact with your database and like give features, like a feature collection to your client application. So that's the core part. The part 2, it's the CRS. We choose right now to not implement that. We can talk later about that if you want, but let's keep it. And the part 3, it's CQL2 filtering, so more advanced filtering, and I'll show some example if I have time. So again, a choice why we. So there are other projects like PG feature serve that exist that are made for serving features from PostGIS. And so, but yeah, we wanted something in Python using Fast API, so it has nice feature and it's fast. Again, so as for TMVT, we just have the database and the TiFeature service in the middle with your application. So the application asks TiFeature to get features from PostGIS, and pretty simple. So the feature of TiFeatures. Fast API, OGC features specification, it can return a lot of different data type like HTML, GeoJSON seconds, CSV, so plenty of response types. It also supports non-geospatial tables. So if you have a tables without geometry, it should handle it. Yeah, it's fully async, synchronous. It's easy to integrate with your own application. So you get the endpoint, you can integrate the TiFeature endpoint to your application if you have already. Right now, we only support table layers, but David Bittner is working on making function available in the next versions. And again, important point, we only need the select privilege. So as for TMVT, it's don't fork it. Just install it. If you have change to make, you can make pull request to the project if it means to make it better. But yeah, you can just import and then customize your own application using the TiFeatures modules. So you can just yeah, launch again TiFeatures, you get nice open API documentation with input, output information. And so we added like a demo, like a viewer, HTML viewer in TiFeature. So that's the landing page when you start the project, when you start the TiFeature application. So you can list the collections like see the items for one specific collections, and and also like see like the specific items. So list all the items, access to the unique items, and also like return, like ask for GeoJSONs or whatever. So so I'm going to do a demo. All right, so I'm going to share my screen again, desktop there. All right, so I'm going to switch to TiFeature project and going to launch. So it should be fine. All right. Oh, yeah. So that's the home page. Oh, I forgot to. Okay, that's the home page. So we can access the API documentation again. So, but yeah, let's go to the collections. So right now in my database, I have 4 tables. So the countries that we were using before. So before we were creating like vector types, but right now we are just returning like GeoJSON feature collections, and with all the properties, and we can change page and like change the number of items we want to return, and that we can go crazy and do like more filtering parts. So I'm going to copy paste because I'm lazy, and oh yeah, we can, for example, like if you want to just show Canada because it's a good country, you can just say you filter the items and say I want only the country which name is Canada, because it's great. You want to only return some properties, you want only to the name. Yeah, you will get only the name. Other like fun stuff to do. Yeah, let's go crazy. And so the secure2 part, the secure2 specification, like enables you like to do more complex filters. So right now I'm going to ask for the countries with more than 40 million people, and with a limit of, I don't remember what I put, 100. So it should print all the countries with more than 40 million people. So, and yeah, I can also sort by the pop est hub. Yeah, and should be properly sorted there. And just one fun thing oh yeah, and I can also use PostGIS function within my filter. So right now I want to only show countries with like a huge area, so that could be a huge area. So we should have Russia, Antarctica, and like Canada and US. So this is like kind of fun stuff that you can put in the filter in the SQL2 with the SQL2 specification. You can like add more stuff to that. And did I add one more? No. Okay. Cool. So I'm sorry for jungling slides. Okay. And I've got 5 minutes. So yeah. So going back to Paul's question, like why another one? Why in Python? So now we have 2. We have TMVT and TiFeature, and we can easily so this is the code base of this page, Like in like less than 100 lines, you can like put the 2 together. So TiFeature and TMVT to create like a OGC feature and tile API. So fully compliant API. So you can take the endpoints from one project and the endpoints from the other project. So you do you from TMVT, import the endpoints, from TiFeatures, import the endpoints, and create like one fast API application that you can deploy in one go. So yeah, that's the different part of the code that does the work. So, but it's pretty simple. Yeah, the performance of the project, it's pretty hard to test the performance, but we found that like returning like a lot of features works well with TiFeatures, and but yeah, there is more to do on this side to benchmark the performance. So again, why? Because we could have all the raster services, the vector services, and the feature services written in Python using FastAPI, using the same code style. So if you ever work with TiTiler code base, you will understand and really see how TiFeature and TMVT works. So for us, it's really it's really easy to like bring all together in one place. But yeah, we felt that having two projects was kind of annoying because we ended up using TiFeature and TMVT in most of our project. So you could still use TiFeature and TMVT, but next month or like pretty soon, we are going to merge both projects into one project called TPG, and where we will we'll try to like bring the feature API and the tile OGC API all together in one project. But yeah, that's pretty much it, just on time.
Well, thank you very much, Vincent, for that talk and showing us your new services. We're coming up to the end of this slot, so I'm going to ask you to stay online as a panelist. And if everyone has questions for Vincent, then you either put them in the chat or even better, put them in the Q&A. That way they have a nice structure. You can go back and see the answered ones. They don't just disappear into the past. Thank you again, Vincent. I'm looking forward to trying out your software in the future. It's very